Hi, good evening. This is my new skirt. It's in like Monet water lilies again, but with a summery note close up, with just a little bit of trimming with I have a slip on underneath. Trimming is this way, closer, and these are more trimmings, more like water lilies. I think this has to be a bit in the center. It seems like it's oh, yeah, that might be the best thing. All right. So, and I have a blue, considering, and for a change of luck, a square dial. It's not staying on my hand; it falls down. But a square, rectangular dial, change of luck. All my research being published, my creative work, and my political essays, etc., being published. So that's what I hope for. Now, first, I'm going to just note that I have an idea for an experiment. All right, this is from Siddharth Mukherjee. Is the song of the cell, but he hasn't discussed it. This, it's he's spoken about stem cells, and I thought if he cells, and I'll sometime do this experiment with you watching me, my readers, after. Um, if yeast cells, which are eukaryotic cells, which are the most basic eukaryotic cells, can be converted to, um, you know, uh, our stem cells, just to check. Beg your pardon? Beg your pardon? So I would be adding saliva, which has DNA, and then transferase, and one of the enzymes. Uh, Many years ago, Professor Baker, had let slip that DNA could catalyze reactions. All right, that did not get anywhere, I guess, but no harm in trying. It's at room temperature, yeast, DNA, saliva, and so to see. So it's and my own DNA. Would it convert it to stem cells? And what I would have to look up papers on stem cells and see if there's a way of testing it's an assay to see if there are stem cells, etc. So that's an interesting experiment. I thought I would do it, but I don't have the right research done yet. So it needs to get it needs more research. So and here goes. This is a FIFA ball. Toronto's hosting, World Cup soccer. So this is a FIFA ball, and I thought I would see. And then there's another one. This is my son's, as a child, and I thought dv by dt plus v is equal to constant. And would this be like as groundbreaking as Newton's, the M2 M1 M1 M2 equal, and M1 V2 is equal to M2 V1, more force of momentum law. All right, so I have a measuring tape here, and so first let's I'm going to kick this and then make this dv by dt. So this is so I'm going to right. This is a little bit uncomfortable, actually. It's a very pretty skirt, but more too much like Cinderella. All right, who's looking for Prince Charming? I'm here trying to. Okay, and then I'm gonna. So this is about. Oh no, I have to continue, but so just to get an idea. All right, so I'm gonna change. So the velocity was 85 centimeter. So I took about a couple of seconds, right? So all right, we'll go back. We'll go back to it and begin again. 85 centimeters, and then acceleration. So dv by dt. So is it a constant? I'm going to do it with both the balls and twice. So this, all right. So that there. So 2001, 2002, 2003, 2004, and so that's acceleration. So it was faster. So distance. Um, uh, So um, this is about 41 for, I think it was just a 1 second. 41 per second square. 85, 85 centimeter, 40, 85 centimeter. So V dV by dt plus V is equal to constant. So 85 centimeter per second, per 4 seconds, 2 seconds. I think I took 4 seconds, right? 4 seconds per second. And this is for 45 centimeters square, so centimeter per second square. So I think that was all I did. So that's the acceleration. So let me to get an idea. 85 by 4, 4 twos are 4 ones are 4 times 2 point 25, and this is just 45 centimeters square. So this is plus this is a math equation. So 60. 66.25. So give this a shot. Mass is different. Mass is different. This with the same ball. All right, same ball. Gonna give this. Let's see if I kick faster, will the same constant come? All right, and then maybe you could try on your own time with a bigger ball or big, because this is my son's ball. If I'm sitting on the couch, he comes, kicks it, and back and forth. I have to kick it back. So let's see this one. Or for 3 seconds. 3 seconds. So that's just a 30, the fraction of a second. So that was all right. 3 seconds, and I came here, picked it from here. This is 87, and 87 for 3 seconds. Or 4 seconds itself, I think. 3 seconds, 4 seconds, 4 seconds. This was really fast. 87 for 3 seconds. This is from here, and it went all the way there. 47 or 48. 48 by, it was faster. So we'll say 0.5 second squared. 45 centimeter per second. So this will be. So is this the same for 3. This is 75, 350. 29 centimeter per second. For 296. 6 plus 29. No, it's not a constant, because 0.5 comes up, right? 98, 96. It's not a constant. We'll just try if a different mass. 15, 1, 3 plus 9, 12, 125. But accurately, if you do, this is not a constant. So it's not as momentous as, but the mass, if I were to consider the mass, m by m, constant by m, but it's the same mass, so it doesn't make any difference. We'll just try once with this. All right, because my son kicks it to me. All right, we'll see. We'll see. So that's 1 second. 1 second. I think I didn't get the seconds right. Did I get the seconds right? I think this is this is two. I think this is two. So you're onto a good thing. If you have two of you, then you get a stopwatch and that sort of thing. I think this is uh, two, so 67. Two. This I got right. Part two, dv by dt I got right. To 67. Or two fours are 4 times 8, 3.5. Oh, this goes up. 43 plus, oh no, it's almost twice the amount. Is there a math here? What do you think? I'll let you try with the bigger ball. All right, they're selling in shoppers. FIFA big ball as well, orange color. 39. So 66.25. That is 66.25. Oh, close, twice, almost twice. So if the velocity is twice, then your acceleration is bound to be twice. Yeah, if your velocity, see, approximately, see, this was not done. If your velocity is almost twice, this was the first one, this is the second one, then your acceleration is bound to be twice, close to twice. So, all right, I'll let you buy a new ball and work it out with the, the other soccer ball, FIFA soccer ball. So who set the FIFA going? I said with you, really, I look ridiculous with a Cinderella skirt. It's a beautiful skirt for a party, but not so, but I have running shoes on. All right, so I did good on one point, on one note. I did good on one note because I have always in my cross trainer. This is my running shoes. These are my running shoes. Reebok. I have tennis shoes too. Yeah, and so here is another. So buy the new soccer ball, FIFA soccer ball, and try this experiment. So if maybe I should try again, or the two of you should do it. Two friends. One of them has to have soccer lessons on his resume. I don't have soccer lessons. So this is, I'm going to get a waffle out and see. Okay, I did the waffle diagonal experiment. So this angle is a right angle. So the two are equal. All right, so that they're well cut waffles. So that you have right angles here and right angles here. And then if I were to cut another circle, they all look equal. All right. I think the vertical ones, longitudinal ones, are maybe a little different angle. We'll see. All right, so this is this is a 90-degree angle this way, and this is, how would I measure this? Okay, this way. This is this is the right way, right? And then this is 30 degrees. So the other one is 60. So this horizontally, this is 90, easy to measure. So it's small arc. So small arcs are usually straight lines, really small arcs. A little bit of curvature there, but this is also This is also 30 degrees. All right. So if I were to draw another circle and see, we'll take a smaller circle. All right, for ease of execution. So this is a possible high school project. So and so this I drew a circle. My compass, was setting. So we'll just so this approximately. I had proved theta is the same, right? For each arc. Oh, my circle didn't come out really good. But, if I'd done a straight line, then that would have been my angle. These two look alike. These two look alike. We'll measure it. Is it, 30 degrees again and 60 degrees? The different circle. All right, this is easy. This is 90 degrees. All right, and despite the fact that I didn't really, okay, 90 degrees. It's 30. We'll see another, the horizontal ones, or horizontal ones should also be 30. But it may not be very accurate because it's a very roughly drawn plot, roughly drawn circle with, lines all over. So, and lastly, with the waffle, what else can you do with a waffle? Do you get concentric circles if you were to go? So if you were to go through the squares, I should have gotten one. You get a. That's the center. So you get concentric circles. So that I guess has some significance as far as the Earth goes. Earth is of course spherical. So that was all I had to discuss today. And happy soccer or football. Happy kicking the football around. All right, and then maybe testing out this with different circles. All right, enjoy yourselves. Thank you.